Yes, good morning, good afternoon, good evening, everyone. Um, I'm James Smith. I'm the CEO and co-founder of a company called Bugsnag. And today I'm going to do a little brief talk about how to protect your applications from erratic or bad behaving SDKs. Um, I have been attending droidCon for a really long time. I don't think I've missed a single droidCon SF. I haven't made it across to any of the other locations yet, but it is one of my favorite communities and one of my favorite conferences to attend as an attendee. And Bugsnag's had the pleasure to work with droidCon for a really long time as a sponsor as well. But back in the day, before I was running a company, and I still get to do this here and there, I have a background in building software, and so I have a background in open source. If you were early Android developer, you may have used some of my Android libraries. One of them was called Android Async HTTP, which was one of the early HTTP libraries that a lot of large Android applications use, like Pinterest and Twitter were using it at the time. Apart from that, I've been running company for about a long time now, 7, almost 8 years. Before then, I was the CTO at Y Combinator startup in the gaming space called HazeApp, which started off as a mobile gaming social network. And before that, I worked in all sorts of technology industries. But really, the common thread is that I love building companies. I love building products. And a little bit more about Bugsnag. We kind of covered this already in the intro, but we are a error monitoring and stability management solution. And effectively, what we do is we detect when your software breaks. We tell you how badly it's broken, where exactly the line of code the bug happened in, and are there key customers impacted, and what should I do about it? And we're pretty broadly used. You probably have some of these applications on your phone, and Bugsnag is powering crash reporting and error monitoring for these applications. There's a few that I wish I could talk about, but we have to keep our logos quiet for some of these customers. But for the ones we can talk about, Pinterest, Airbnb, Lyft, Square, a lot of these applications are used every day by a lot of people. So today I'm going to talk a little bit about some incidents that happened recently, more as an example, not to throw shade on Facebook, but some incidents that happened recently that I think that we can learn from. Now, if you hadn't been paying attention, there were 2 outages recently that caused applications worldwide, iOS applications worldwide, to crash at boot. And this was terrifying, not only because crashing at boot is almost the worst case scenario, but also because this crash at boot was caused by third-party SDKs, and one of the major crash reporting platforms out there was unable to cope with the volume of crashes coming in, so shut down. And therefore, developers had no visibility into these crashes. So what happened? Well, pretty much every major iOS application that implements Facebook authentication or Facebook sharing, i.e. uses the Facebook SDK, was at the whim of a change that Facebook made to their APIs that their SDKs consumed. What actually happened under the hood was a little bit more subtle than that. There was a change to the data format, the data structure of data that was sent back from Facebook's APIs. The iOS Facebook SDK was not expecting the change to this data structure. So really, effectively, it was the position of an element in a JSON element was moved. And so rather than getting a dictionary back, it started sending a Boolean back. And that's not great if you don't expect that data format to change. And so the Facebook SDK was like, hey, Facebook API, give me this information. Facebook API gave it back. And then the iOS SDK just went, uh-oh, I don't know what to do about this, and crashed the application. And it didn't just crash that little bit of code. It wasn't protected. It crashed the entire application. And because so many of these applications use the Facebook SDK to authenticate or to pull data at boot, it caused applications to crash at boot. Unfortunately, this happened twice, and I'll talk more about that later on, but the exact same bug was observed in 2 separate incidents with Facebook changing their API. Obviously, we're at droidCon. My background is Android. The reason I call this out is this is not a unique problem to iOS applications. Just because iOS apps got screwed worldwide doesn't mean that us Android developers can say no problem. So in my brief talk today, I'm gonna talk about what you can do to protect your apps when SDKs start behaving badly. And I've kind of broken this into 4 sections here, and I'm going to go through each one. I'm going to spend a little time on the first section on remotely turning on and off SDKs. This is probably one of the most important ones you can think about and do. But 2, 3, and 4 are definitely more my area of expertise. I work with engineering managers and engineering teams from some of the world's largest mobile companies, and we talk about strategies for managing stability and crashes all the time. So I'll touch a little bit briefly on 1, and then we'll dive into 2, 3, and 4. So I kind of mentioned a touch on this already. This happened twice. May the 6th was the first outage, and this is when iOS applications worldwide started crashing. And it was in the press, and everyone was getting stressed out and getting paged. But the scary thing is, this happened again on July the 9th, and it happened the exact same way. It was the same bug, it was the exact same change to data format and data structure, and the SDK crashed in the exact same way. And unfortunately, some of the exact same iOS applications got caught out by this bug. So the reason I point this out is these errors can happen not as part of a code change. These errors can happen as part of a third-party external activity. Now, this isn't just true for SDKs. If you have a reliance on any third-party API and that API has a bug in it, then you probably don't want your application to crash. Depends how heinous the bug is, but if you can avoid crashing your application, then you should. And if turning off the SDK will stop your application from crashing, then absolutely you should do that. Now, there are lots of strategies for doing this. A lot of large mobile studios will have their own feature flagging system. Typically, feature flagging is not just used for testing new features. Oh, let's roll this out to a subset of our customers. But feature flagging is used as a kill switch, as a remote switch. And if you already have the system in place, then it's really important that you find a way to wrap your SDKs in kill switches. It's not always obvious to figure out how to do that. Some of these SDKs do sneaky techniques to boot up really quickly and avoid being disabled. But talk to your SDK provider, because there almost always is a way to do this. So if you're not using your own feature flagging system, I would check out products like LaunchDarkly or Split that provide feature flags as a service, and this will help you get this kill switch enabled. What about these other techniques here? Well, hopefully most of you are doing number 2. Number 2 is monitoring stability. Now, if a lot of people use the free to market options like Firebase Crashlytics. Firebase Crashlytics is great if you are using a tool like Bugsnag or another equivalent grown-up error monitoring tool. You get a lot more information. Not only do you get what we call a stability score, which is effectively an error rate, it's crash-free sessions, but it also gives you a lot more information. We'll capture a stack trace, we'll capture thread dumps, we'll capture breadcrumbs, we'll capture device analytics. We'll also capture ANRs in Android, and we capture OOMs in iOS. We capture OOMs in Android as well, but they just show up as a JVM error. What you're looking at here is what we call our stability center. This shows you all of your applications, and it shows you the stability over time of those applications. And you can also see that green line and red line, which is your target stability and your critical stability. And if you see your stability crash, like you see in this screenshot here, it might be an indication that there's a problem, like an SDK outage. Now, I already mentioned this, but Bugsnag not only detects exceptions in the JVM, NDK errors, but it also captures application freezes and ANRs and captures a stack trace. And so we're the only platform, as far as I know, to capture ANRs outside of the Google Play console. And the Google Play console just captures a few example ANRs and doesn't give you full context. So we capture a stack trace and we capture that full device breakdown as well, and the device information. And if you are capturing crashes, great. But what if an SDK introduces an application freeze? What if, for whatever reason, some SDK is doing something on, I mean, this is pretty much impossible to do these days, but what if one of your SDKs is doing work on the UI thread and locking up your UI thread while it's doing a network request? I know this is the sort of problem that we should have solved years ago, but what if they're doing that? Well, again, if you know that that's happening, which is the first part of this, then you can turn on the kill switch. Another way to do things here, and this is more of when you roll out new SDKs, that's what I've been talking about before, is when SDKs go bad, when they suddenly go bad. But actually, it might be risky to roll out SDKs in general. There are some types of SDK, and again, I don't want to throw shade here, but there are companies that aren't experts in writing SDKs. We have to be, because our SDK detects crashes, so we have to not crash. But there are some SDKs, ad providers and ad networks, for example, where their expertise isn't necessarily in writing SDKs. So let's say that you've been instructed that we want to roll out a new ad network. Well, maybe you want to do that by A/B testing it. Have old ad network in bucket A, new ad network in bucket B, and then roll the new ad network out in a phased rollout using this A/B testing platform. If you do that, not only can you see if your SDK is performing well and behaving well, but you can then use tools like Bugsnag to see if there are crashes that are disproportionately affecting certain experiments. We have, this is really where the segmentation and search is really where we shine outside of these early first generation crash reporting tools. You can say, show me all bugs affecting this active experiment or A/B test. You can look at the stability of that particular A/B test, and then drill down using our search interface. So I've kind of talked a little bit about kill switches, and then I talked a little bit about stability and how to adopt that as a KPI. But here's some kind of quick pro tips across the board, right? Capture every error to gain actionable insights, not only when there's an issue with SDKs or APIs, but also when you do releases. Customize your alerts so you know when one of these incidents happen. Connect it to your incident management tool like PagerDuty or whatever you're using. Get a deep dive into error diagnostics, and then monitor stability of SDKs and A/B tests. Now, obviously, I've called these out. We've built a platform that does all of this because we know these are essential to mobile development. I got to mention this. During these Facebook SDK outages, we were able to provide continuous monitoring throughout the entire time. We didn't drop a single crash report. We didn't turn off our error reporting APIs or endpoints. There are providers out there that I may have mentioned already in this talk that you are probably familiar with that kind of shrugged their shoulders and turned off everything and gave up. I get it. Operations and infrastructure and scaling is hard, but when it is your business and when it is something that we take pride in, the fact that we didn't drop a single error report with the volumes of errors that looked a lot like this. I'll leave you with some community good practices here. I really love this comment. If you were following the Facebook outages, there was some lively discussion on the Facebook SDK GitHub repo. And they locked the thread at one point, unsurprisingly, but there was a lot of really positive discussion as well, right? People are saying, hey, Facebook, what happened? How can we figure it out? But actually, people want to know these kind of things. If you're using an SDK, what features are being turned on and off remotely? Why are they being loaded at launch time? Where can I find documentation for behavior? How can I turn these things off? And can we use kill switches? These are really good things to consider. Now, SDK providers don't always give you the answers to these questions. That's okay. Part of using new SDKs is you take on a little bit of risk of lack of documentation or whatever. But if you answer these questions yourself about bringing on a new SDK, it allows you to be more defensive about implementing and using SDKs. So shout out to Patrick Danino for this comment, because I think it was nice and thought-provoking. Right, I've got a little bit of time for Q&A, so if I load up the Slido tab here, if anyone has any questions.
Yes, we do, and yes, we have questions. First of all, thanks so much for the amazing talk, James. It was really insightful on what you guys are doing over at Bugsnag and how you're helping all the developers. I'm gonna hand it over to Jan, who has the screen ready with the question. So you can take it away and answer that.
Great. Fantastic. Yes. Does Bugsnag provide crash tracking for SDKs? For example, Crashlytics doesn't support crash tracking for SDKs. So we are actually used in a lot of large SDKs deployments. It is possible to use Bugsnag in SDKs. It is not something that is common or supported because it's very tricky. One of the things to consider with error monitoring SDKs is how do you isolate your crash detection just to the code that is part of the SDK and not to the broader application. So this is not something that is you get out of the box without doing any extra work, but it is technically possible. What you need to do effectively is to use one of our after crash callbacks. I think we call them on error now. So there's a callback that fires every time we detect an error, and you can basically look at the stack frame and say, is this part of the SDK or is this part of the application that the SDK is included in? So as an SDK developer, you can technically use it. But I would say one of the concerns that people might have is if you're monitoring SDKs, Bugsnag is a commercial product. We are not a free product. We charge for the product, and the more crashes you have, the more expensive it is. So one of the concerns is that if you're deploying this in an SDK, you want to only report bugs that are in your SDK and not bugs that are in the broader application. So it's not an officially supported workflow, but we do have large major customers that are doing SDK monitoring. Question here from V. Can we try Bugsnag for free on a trial? Yeah, you can. We have a 14-day free trial, and you can kick the tires on every feature during a 14-day free trial. And outside of that, we have for certain larger deployments and larger companies that may need a bit more of hand-holding and a little bit more help, we also do proof of concepts. So slightly longer than a trial, we'll work together to say, what do you want to get out of this process? And we'll help you make sure that you do get everything you want out of a Bugsnag trial effectively. So yeah, free trial. Go to bugsnag.com and sign up yourself for a free trial.